In this video, we will cover plastic and elastic deformation. This includes definitions of plastic and elastic deformation, their positions on the stress-strain diagram, and illustrations of how several types of materials behave under both elastic and plastic deformation. Understanding plastic and elastic deformation is of key importance in material science and engineering because these principles determine how a material deforms under loading and unloading. Before we define elastic and plastic deformation, let's define stress and strain as they quantify deformation. Stress is force applied over an area, or a pressure force. Strain is the change in length in the direction of load, a stretching or compression. Elastic deformation is a non-permanent deformation. This means the material will deform under an applied load. However, when the load is removed, the material will revert to its original shape. In elastic deformation, under loading, the bonds between the individual atoms in the lattice are stretched, allowing the material to deform. When the force is removed, the bonds, and also the material, revert to original shape. In plastic deformation, when a load is applied to a material, it deforms. However, in plastic deformation, the load does not revert to its original shape. This is due to microscopic dislocations. When these dislocations are introduced into a lattice, they permanently alter the structure of that lattice. Thus, a plastic deformation is a permanent deformation. On the stress-strain diagram, in the elastic deformation region, the region of the stress-strain plot corresponding to the elastic deformation is linear. The slope of this line is known as the modulus of elasticity. This gives the formula stress equals modulus of elasticity times strain. The point on the graph where the deformation shifts from elastic to plastic is called the yield point. The yield strength is the stress that is required to cause a plastic deformation. By convention, we define plastic deformation as a permanent strain of over 0.2%.